Here's an update on the micro ROV build. This is the ROV. It's based around a HD camera. Today we're going to be looking at the control panel and the basic wiring. The micro ROV uses 12 volt DC brushless pumps, air pumps, the sort of things you would use in a garden fountain. Simple 2-wire connection, positive and negative. These pumps, which we'll call thrusters, are mounted around the periphery of the ROV to give forward propulsion, reverse, lateral sidewards, left or right. And we can rotate the ROV by just using either bank of the thrusters on their own. Powering up the left bank of thrusters rotates clockwise, and powering up the right bank of thrusters on their own rotate anti-clockwise. Okay, so let's have a look at the wiring of the thrusters. Throughout the test I'll be using a single pump motor to check that what we see on the control panel is what the ROV will eventually get as power. So if I turn the thruster control, we'll see the LED display increment as a percentage of power passed to the thruster. We have controls for the left bank of thrusters for forward movement, the right bank of thrusters again for forward movement. We have a potentiometer with a knob for lateral left movement, lateral right movement, reverse, and this central button potentiometer is for air assisted buoyancy, to bring the ROV back to the surface after a dive. So to recap, these displays are for both the forward controls, showing a percentage of power that the forward thrusters receive. Okay. Beneath this panel are the motor control units, individual for each potentiometer, linking to each bank or single thruster. Here's the umbilical. I've marked each of the cables so I know in future if a cable becomes disconnected I know where it's supposed to go. And on fault finding, if one of the thrusters doesn't get power, I've got a starting point. The other side of the multi-block connector, which you see has strain assisted lanyards on either side, taking any strain off the wiring. This will be disconnected and connected a few times over the coming months as I test the ROV. I've gone for a block connector that splits apart so this can stay with the control box and this being part of the umbilical can stay with the ROV. Very convenient, it just pushes together. Hopefully it tests as good as it looks. The rest of the umbilical is just a 20-meter cable, the sort of thing you would connect telephones with. Ending in pairs, conveniently. There's enough pairs to suit my ROV project, and they have a bolt colour and then a white and striped similarly bolt colour, so fault finding is assisted. So that'll be the ROV end eventually. 20 meters is a starting point. Okay, we're now going to power up the control panel and use a single thruster to test each output. Picking up the wiring stroke thruster test. This thruster is being used to test the wiring before connecting the wiring to the ROV. So tracing the wiring for the left bank of thrusters, forward left leads to red, and red and blue. Red and blue at the other end of the wiring. Connecting to the test thruster. And we hear the thruster fire up, showing we've got power at this end of the umbilical, and then I can go ahead and wire it to the appropriate thruster bank on the ROV. So we would test each of the potentiometer rotary controls, trace it to the umbilical and establish which pair are controlled by which rotary potentiometer on the control panel. So the next step is to repeat the process and then subsequently wire the newfound colour coding to the appropriate bank or single thruster on the ROV. I'll stop at this point and we'll carry on later. Thanks for watching.